here we go. This is exam 3. So what this is going to cover is some overlap from the temperature conversions. There are some unit conversions, but mostly this is going to get into things like we're starting dilutions, we're talking about allegations, um, we're talking about more institutional pharmacy type things. So number one, don't forget your conversions. Number two, we'll talk about some things involving percentages and calculations of the percentages that you need to remember. So let's get into it. So this is a Fahrenheit temperature to Celsius. We need to convert it. So 98.6 to Celsius. If you remember, that right there is a number that I need to remember, 98.6. So you probably, hopefully, already know that. 98.6 is normal body temp, which is 37 degrees Celsius. But I'll go ahead and show you the math behind it. So we have 98.6 minus 32 times 5 divided by 9. Okay. That is 37 degrees Celsius. Okay. So this is based on weight. So based on a patient's weight, use what unit? That is going to be the basic unit, kilogram. Kilogram is going to be the unit we're going to use for measuring patient's weight. So this is a percentage. So we have a 10% cream. So what I want you to remember is that 10% cream means that it is based off of a weight. This is not necessarily a volume like it would be with a solution. So when we're talking about 10% of a cream, we're talking about 10% of the total weight. So it says how much is needed to prepare 30 grams of this compound. So basically what it's saying is the ibuprofen 10% cream, 10% of the final weight is going to come from pure ibuprofen. So what you need to do is find 10% of 30 grams. So first things first, to find 10% of something, we need to convert that into a decimal. So 10% in a decimal form is 0.1. How you do that is you do 10 divided by 100, or just 10 in the decimals right there. That's 1, 2 decimal places. So it turns into 0.1. So now that it's the decimal form, I can do an operation that's going to tell me what 10% of 30 grams is. So 30 times 0.1 is 3 grams. And just double check yourself. If something is 10%, 10%, okay, so let's say the whole amount is going to be 100%. 10% is 1/10 of the whole. So if 3 times 10 is 3 times 10, 30. The answer is yes, so that makes sense. We're going to convert this to Fahrenheit. So just remember that our formula for Celsius to Fahrenheit is going to be our temperature in Celsius, so 15. We need to do times 9 divided by 5, and then we need to add 32 to it. So we have 15 times 9 divided by 5 plus 32. And I get 5 degrees Fahrenheit. Okay, this technician has been given 100 mils of a 10% solution. They need to dilute it to 500 mils with sterile water and then to label it. What percentage should appear? So what you need to do here is say, okay, I have a 10% of a 100 mil solution. How much drug do I have? So the first thing that I'm going to do is okay, so on the first question on this test that involves percentage, I'm going to tell you, when you see this, you should think number grams over 100 mils. Okay, that never changes. That's going to be the same every single time you see this percentage. Okay, so that being said, our 10% is going to be 10 grams over 100 mils. So how many grams is in that 100 mils? Well, that's just going to be 10. 10 grams of acetic acid. Okay, so that's telling us the drug component of our problem, because now we're going to dilute it to, so if we're diluting it to 500 mils, we're going to start with our solution. So imagine this is a cylinder with 100 mils of water. I'll go ahead and make it blue. Right. I'm going to use a highlighter, actually. I think that'll look better. Okay. And then we're going to dilute it to a container that is how big? It's going to be 500 mils, so it's going to be bigger. Okay. Okay. So that means in that situation, we did not change the drug. You know, the acetic drug, acetic acid, I'm sorry, is the same amount in here. All we're changing is how much water is in it. So because we have our 10 grams, we know that our 10 grams is in 500 mils of whatever, of solvent. Okay, so on this side, we need to figure out what percentage that is. And like I said, a percentage is grams over 100 mils. So in this instance, we don't know this top number. So we need to do 10 times 100 divided by 500, which is going to be 2 grams or 2% strength. That's our answer. So this one is a ointment as well. So 14 grams added to 25 grams of 0.2% hydrocortisone. What will the percentage be of hydrocortisone? So in this instance, we have 25 grams of a 0.2. So it's hydrocortisone, but it's already diluted. We don't know how much hydrocortisone is in that 25 grams of 0.2%. And we need to base our percentage off of drug, off of pure drug. Okay, so we first need to find out how much hydrocortisone is in this. So how we do that is we take our 0.2% and turn that into grams. I'm sorry. Our 0.2% of a solid is actually 2% of the weight. So how much weight do we have with the hydrocortisone? We have 25 grams. Okay, and then just like the previous problem, when we had a percentage, the first thing we needed to do was convert it to a decimal. So 0.2 divided by 100 is 0.002. So if you do 25 times 0.002, you will end up with the number of pure hydrocortisone. Okay, so that means that there was 0.05 grams of pure hydrocortisone, and there still is, right? So in this instance, we are having a cream. So in this instance, we have our original cream, which was 25 grams of 0.2%. we're turning that into something with this other ingredient, petrolatum. So we have our 25 grams still in there. We didn't take that out. But then we're adding our petrolatum, which we added 14 grams. So in the end, we only have one active ingredient, which is our hydrocortisone, and then we now have a petrolatum, which if you remember anything about adding water to something, water doesn't matter. You know, water is 0%. So in this instance, petrolatum you could consider as 0%. Okay. All we're doing is changing the volume or the amount. So now we have our 0.05 grams of hydrocortisone in how many grams? 25 plus 14. That is 39 grams. So now what we need to do is figure out what percentage of hydrocortisone there is per weight of drug. So it's literally 0.05 divided by 39 times 100. That turns into a 0.128% hydrocortisone. 0.128, we'll call that 0.13. Okay, so it makes sense because we started with 0.2 and we just diluted it. We added that petrolatum, and so it's going to get smaller. A physician orders a liter of half strength. The pharmacy has full strength, which is 0.5. How many mils of the stock are needed? Okay, so there's quite a bit here, but we basically need a liter of half strength. So right there, if that is full strength, what is going to be half? Well, it's going to be 0.5 divided by 2. So we need a liter of 0.25%. Okay. So let's do the 0.25 grams over 100 mils. And then we're going to do how much we need. So it's a liter. We need a liter, which by the way, a liter is 1,000 mils. Okay, so the 0.25 times 1,000 divided by 100. So that means we need 2.5 grams of Dakins. So, and that's saying pure, right? But we don't have pure Dakins. What solution do we have? We have half strength. So we need to say we need 2.5 grams. We don't know how many mils, but we know that our half strength solution, because it's 0.5%, it's going to be 0.5 grams over 100 mils. So 2.5 times 100 divided by 0.5 is equal to 500 mils. And it makes sense, right? Because if we need a liter of half strength and we are using full strength, then we just need half that amount. So, but mathematically, I wanted to show you guys that it's 500 mils. You're preparing a TPN with 500 mils of 7.5 and 500 mils of 50%. What is the final percent concentration in this TPN? So basically, we need to understand that it's asking for just Travasol in this situation. So we need to say, okay, we have a drug, and then we have a full, full volume, which is all of them together. What percentage does the Travasol contribute? So the total volumes is going to be this plus this. Those are our only ingredients. So what's 500 plus 500? It's equal to 1,000 mils. Okay, so let's look at the Travasol component. 500 mils of 7.5. So the 7.5% turns into 7.5 grams over 100 mils. And we are going to add 500 mils of that. So 7.5 times 500 divided by 100 is equal to 37.5 grams of Travasol. Okay, so that means that 37.5 grams is of our 1,000 mils, because remember we're adding 500 mils of one, 500 mils of the other. What percentage strength is that? So we just need to do 37.5 times 100 divided by 1,000. That is 3.75%. Okay. In this problem, this is sort of a limiting stock problem because you have 50 mils of 80%. You're going to need to make as much 35% as possible. How much water will you need to add to the 50 mils of 80%? So basically what this comes down to is the fact that you only have a certain amount of drug. So first step of this problem is figuring out how much drug that is. So you have an 80%, which is 80 grams in 100 mils. How many mils of that 80% do you have? You have 50. So 80 times 50 divided by 100, you have 40 grams of dextrose. So that's 40 grams of pure dextrose. But in this problem, you're going to need to make 35%. So you will take your 35%, and then you're going to say, okay, I only have 40 grams. How many mils is that going to make at that percentage? So my 40 times 100 divided by 35, that's going to make 114.28%. I'm sorry, 114.28 milliliters of final product. But in that problem, you have to remember that you did not start with a pure dextrose solution. It wasn't 100%. That doesn't make sense. So in this solution, you started with a 50 mil solution. So what is 114.2, we'll call it 29, minus 50 mils? It's going to be 64.29 mils of water. Okay, is that an answer choice? Yes, it is. So the reason that I subtracted that is because it asks how much water you need. It doesn't ask how much final product can you make. It asks how much water do you need to add to that to end up with your percentage. A prescription is written for acyclovir, 1,200 milligrams, micronized 0.12 gram, blah, 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 blah. How many 200 milligram capsules are needed to prepare this compound? So right there, there's a lot of words, but basically it's saying there's going to be 1,200 milligrams of acyclovir in this compound. If you have 200 milligram capsules, how many do you need? So it's literally just 1,200, just right. Twelve hundred milligrams divided by 200, that is 6 capsules. That's a lot of words, but basically it's just asking how much you need. A technician has 50 mils of a 0.5% what will be the final percent strength if she dilutes it to 125? So just remind yourself, in this problem, we have 50 mils of a 0.5%. Okay? So just remember that this is already diluted. This is not pure, this is not a solid, it's already diluted. But in this problem, she's going to turn that into 125. So the drug is not changing. All that's changing is the amount of solution it's in. Okay, so we need to first ask ourselves how much drug she has. So it's 0.5%, so that's 0.5 grams in 100 mils. She has how much? 50 mils. So 50 times 0.5 divided by 100. That's 0.25 grams of pure drug. So it's going to be percent strength in that 125 mils. So it's going to be 0.25 over 125, because that's the final volume, is equal to x over 100 mils. So when you're trying to solve percent strength, you always look for x over 100 mils. 0.25 times 100 divided by 125, that is 0.2%. You have on hand 2%. How many mils are needed to prepare 0.4 liters of a 1% solution? Okay, so right there, I already know just by looking at that, because my percent strength formula is in milliliters, I'm going to go ahead and convert that. 0.4 liters is equal to 400 milliliters. That's 0.4 divided by 1,000. I'm sorry, times 1,000. So we need to make 400 mils. We don't know how many grams of a 1%. So I kind of wrote that upside down, but just remember that's the 1%, so it's 1 gram, 100 mils. So I'm going to do 400 times 1 divided by 100. So that means that I need 4 grams of drug. So I have a 2% solution, so I have a 2 gram over 100 mil solution that I only need 4 grams of. So 400 divided by 2. You guessed it, 200 mils. Convert the following Fahrenheit temperature to Celsius. So this one I'm not going to work out because so convert this one to Celsius. Okay, so just remember, this one can trick you because you might just do what I almost did and look at that 0 degrees Fahrenheit and say, okay, that's 32. Well, if you remember, 32 Fahrenheit is 0 Celsius. So we actually have to do some math. So that's going to be our 0 minus 32 times 5 divided by 9. And that's going to be negative 17.8. Okay. Penicillin is one of those weird ones that is not measured in milligrams, it's measured in units. So instead of being confused, you could think of it as milligrams, it's just how it's measured. So we have 20 million units. The directions are to add 32 mils of sterile water to reconstitute it for 500,000 units per mil. What is the powder volume Okay, so this one starts a new topic because we have final volume equals powder volume FV equals PV plus DV. And I know it's dumb, but I'm going to go ahead and say it again. You can think of it like you're making Kool-Aid, right? The Kool-Aid powder, water, and you could assume sugar. All of that together makes your Kool-Aid, right? Each of those components by themselves doesn't mean anything. Your powder by itself and your diluent together, they make your reconstituted solution. Separate, they mean nothing. So just remember, we have, and I'll draw a picture on the first one, but I'm probably not going to draw a picture for everyone. So we have a vial, and I'll do my best. Okay. So how much drug does this vial contain? It contains, and this is drug, 20 million units. Okay. So this layer, which I'm going to do in red, that layer is my penicillin. Okay. So I'm going to add 32 mils of water. So this right here is going to be water, which, if you remember correctly, diluent means to dilute or to, put into solution. That's going to be how much water you're adding. So we added 32 mils. And I'm going to color that one blue. Okay. So that right there is two components that we need, right? We need PV, DV, and FV. So let's go ahead and identify which one we have. We have DV, which is 32 mils. But then you're thinking to yourself, I don't have another volume. I don't have another volume. Well, let's look at this problem. Is there anywhere else that's mentioning anything about mils? It's right there. That is our final concentration. So the word final right there means that it is the finished product. So what that is connecting our final volume with our drug because we have 500,000 units per 1 milliliter. In our entire vial, how many units are there? 20 million units. And we don't know the final volume. But because that our final concentration is going to be 500,000 per 1, we can go ahead and do some math. So 20 million divided by 500,000 is equal to 40 mils. So, like I said, that is connected to our final volume. Okay, so I'm going to go ahead and throw that over here. And based on our equation, FV equals PV plus DV, if we have 2, we can solve for the other. So we have 40 is equal to 32 plus X. So you're probably thinking to yourself, okay, well, that has to be an 8. So PV is 8. Okay. If that 20 million units, okay, well, that was kind of dumb. It says 8 mils. 8 mils. What is the final concentration of 92 mils? Okay, so this one changed it a little bit, right? We have our powder volume, we have our units, okay? But we're changing our diluent. So our diluent is going to be 92. So now we have a powder volume of 8 mils. A final is FV equals, do we have PV? Yes, we have 8, and we have DV, 92. So FV has to equal 100 mils, okay? So our final volume, the entire thing mixed up together, is 100 mils. And how many units do we have? 20 million over 100 mils. That's going to be 200,000 per mil. You have 4 fluid ounces of a 50%. You add 500 mils of sterile water. What's the percentage strength of the final solution? Number 1. So ounces is how many mils? Is 30 mils. Okay. So if you have 4 ounces, you have 120 mils. Okay. So we have 120 mils of a 50%. So 50 grams over 100 mils. So how many grams are in our 120 mils? It's going to be 60 grams. Okay. So you add 500 mils of sterile water. So I'm going to draw this out because this one is a tricky one. So I'm going to go ahead and write the amount in mils because we already converted it, because we know that this is 120 mils. So right here, this is where a lot of people will get this question wrong, because they're like, okay, add 500 mils of sterile water, so that means my final volume is 500 mils. No. So you added 500 here. That 120 mils in the beginning did not just disappear. I'm going to redo that. That was ugly. Okay. That did not just disappear. It actually got bigger, right? You are adding more water to it. So what is 120 plus 500? 620. Okay. So now our 60 grams of drug is in 620 mils. We need to know what percentage that is. When you're trying to find percent, you do x over 100. So you do 60 times 100 divided by 620. 9.68%, we'll call it 9.7. Okay. So just remember on that one, this term right here, 2, that's an important word. You're supposed to add 4.2 mils of sterile water to 1 gram of powder to give it a concentration of 200 milligrams per mil. You're looking for powder volume. So I'm going to go ahead and write that. So you're adding 4.2 mils of sterile water, so that is going to be our diluent. One gram of dry powder, concentration of 200 milligrams per mil. So just like on the previous problem, when we had a final concentration, that is going to connect to our final volume. So our 200 milligrams per 1 ml is going to link directly to our final volume because we only have so much drug. We only have 1 gram, and 1 gram is how many milligrams? 1,000. So doing 1,000 divided by 200 is equal to 5 ml. That's our FV. Okay, and like I said earlier, if you have two components in an equation with 3, 5 is equal to 4.2 plus x, that x is going to equal the difference, right? 5 minus 4.2 is 0.8. So 0.8 is going to be my powder volume. How many tablespoons are in 1 pint? So 1 pint is equal to how many cups? 2 cups. 1 cup is equal to how many ounces? It's going to be 8. 1 ounce is equal to how many mils? 30. And lastly, I'm sorry, whoops. Tablespoon is how many mils? 15. Okay, so let's work this out. So right now we are at 2 cups. So each of our cups has 8 ounces. So we're going to do times 8. So that's 16 ounces. So our ounces are 30 mils each, so we need to do that times 30, which is 480 mils. And lastly, our tablespoons are 15 mils each. So just remember, that one's a little different because 1 tablespoon is 15 mils. So you need to divide. And that is equal to 32. So this vial contains 500 milligrams. Addition of 1.8 mils of sterile water will lead to 250 milligrams per mil. What is the powder volume? Okay, so once again, I'm going to write FV, DV, and PV. Okay, so do we have any of those outright? Addition of 1.8 mils of sterile water, so that's going to be our diluent. Okay, so like you probably remember from the last one, when it says final concentration, that's going to be directly linked to our final volume. So we have 250 milligrams per 1 mil. And then how much drug do we have? We have 500 milligrams. So 500 milligrams, what's going to be our final volume? 500 divided by 250 is going to be 2. So that's our FV. So we have 2 mils is equal to 1.8 mils plus X. What is the X? It's just 2 minus 1.8, which is 0.2 mils. You dilute 50 mils of an 8% solution to 500 mils. What's the percent strength? So how much drug do you work with? That's a good question to ask yourself right off the bat. So we have an 8% solution. So that's 8 grams over 100 mils. And how much of it do we have? Well, we had 50 mils. So 8 times 50 divided by 100 is equal to 4 grams. So in that 50 mils, we had 4 grams. That makes sense because we used half of that amount, which is 4. But right there, do not get confused, right? Because we are taking a 50 mil and we are diluting it to 500 mils. So is 500 going to go here or here? Well, if we dilute it to 500 mils, that means it's going to be here. Okay. So remember, diluting it to or diluting it with are two different things that mean way different things. Okay. So just remember to understand that the word to will change your answer. So our 4 grams is going to be in 500, whoops, our 4 grams is going to be in 500 mils. What percentage is it? 4 times 100 divided by 500 is equal to 0.8%. Okay. Convert 1 pint of Bactrim suspension to fluid ounces. So we're going from pints to ounces. Once again, 1 pint is equal to how many cups? 2 cups. 1 cup is equal to 8 ounces. Okay. So 1 pint is 2 cups. Each of those cups has 8 ounces in it, so it's just 2 times 8. A prescription is written for allopurinol, 20 milligrams per mil, plus OraSuite 1:1. How many tablets of allopurinol 100 milligrams to prepare 150 mils? Okay. So this one, I'm going to draw a picture. So I'm going to draw a little bottle. Not very great. So this bottle is going to be how big? It's going to be 150 mils. Okay. So that's our entire solution right there. In that solution, it's going to be what strength? 20 milligrams per mil. So that means every single milliliter of that 150 mils has 20 milligrams of the allopurinol. So by calculation, you can do 150 mils contains how many milligrams? If there are 20 milligrams in every single mil. So 20 times 150 is 3,000. Okay. So there's 3,000 milligrams total, and we have a 100 milligram tablet, so we just need to do that divided by 100. And you should get 30. 10 mils of sterile water, let me change that color back. 10 mils of sterile water added to 1 gram, giving it 10.5 mils of final volume. What is the concentration? Okay, so this is a little bit different because it's asking you the concentration, not asking you final volume. But if you remember last time, the words final volume and final concentration are linked. Okay, so I'm going to go ahead and write FV, PV, and DV. Okay, so we have our FV, PV, and DV, but we need to identify them. So it says 10 mils of sterile water is added. So 10 mils of sterile water added, that's going to be our diluent to 1 gram vial, giving it a 10.5 mil final volume. That right there. So if we have FV and DV, we already know what PV is. There's going to be, what's the difference? 0.5 mils. Okay. So our 1 gram is 1,000 milligrams. And what is the final volume that's going to be in? It's 10.5 mils, which 1,000 divided by 10.5 is going to be 95.24 milligram per mil. You have 300 mils of a 20% solution and 400 mils of a 5%. You mix them together. What's the percentage strength of the final solution? So basically, you might think this is an allegation because it has two different percentages, but we're really not trying to find a percentage. We're trying to, or we're not trying to shoot for a percentage. We're trying to evaluate what they are. So we're going to figure out how much drug we use of each. So we start with our 20%. How much of it do we use? 300 mils. So that's that one. I'll call that A. And then B, we have 400 mils of a 5%. Okay, so 20 times 300 divided by 100 is 60 grams. 5 times 400 divided by 100 is 20 grams. Okay, so now we have 60 grams of A plus 20 grams of B. What is the percentage strength of the final solution? So just remember, final solution, percentage strength of the final solution and percentage concentration are linked. So what we need to do is ask ourselves, okay, what volume of each do we use? So we had 400 mils of that one, 300 mils of that one. Together, they make 700 mils. So I'm going to do 80 divided by 700. Well, actually, I'm going to set it up like properly. Okay, so that'll be 80 times 100 divided by 700, which is 11.43%. What is the percent strength of a solution when 300 mils of 95%, 1,000 mils of 70%, and 200 mils of 50% are missing? So it's basically, it's going to be the same thing we did last time, except we have 3 compounds. So we have our 95%. How much? 300. And we had 1,000 mils of 70%. Okay, so we have our 70%, and then the last one is going to be our 50%. And we had 200 mils of that. Okay, so let's go ahead and calculate how many grams of each compound we have. All right, so we ended up with 285 plus 700 plus 100, which is 1085 grams. So the last step that we had to remember from last time is that we had to add all those volumes together. So we had that in 300, 1000, and 200. So I'm going to do 300 plus 1000 plus 200. That is 1500 mils. Okay, so the last thing we need to do is say, okay, what percent strength is that? So I have 1085 times 100 divided by 1500. And I'm going to get 72.3%, which is correct. You're going to compound a TPN with 500 mils of 10%, Travosol, 250 of 70%, and 350 of sterile water. You're finding the Travosol. So it's going to be a similar thing as the other TPN problem. Okay, so really in this one, since we're just isolating Travosol, we don't even need to consider dextrose. We need to do our 10%, which is 10 grams and 100 mils. How much did we use? So that's 50 grams of Travosol. But the last part we need to understand is that we have 3 different ingredients that have volumes. So we need to add them together. So we need our 500 mils plus 250 mils plus 350 mils of sterile water. Okay. Travosol, dextrose, sterile water. 500 plus 250 plus 350 is 1,100 mils. So we have 50 grams of Travosol in 1,100 mils. What is the percent strength? And you should get 4.55%. You dilute 75 mils of a 30% to 500 mils. What is the percentage strength of the final solution? Okay. You have 30% and you have 75 mils. How much drug did you start with? 75 times 30 divided by 100 is 22.5 grams of drug. And remember, you're diluting at 2. So I'm going to draw my pictures. You started with 75, and you're going to what, 500. Okay, I'm going to color them in. Okay, so you're going to put your 22.5 grams in 500 mils, but what is the percent strength? That should be 4.5%. You add 10 mils of sterile water, 1 gram of drug, powder volume of 0.8, concentration for the final solution. FV, PV, DV. Let's see if we have any of those out right. Sterile water, 10 mils. Oh, it gives us powder volume right out, 0.8. So if we have the powder and the diluent, those together make our final of 10.8. So because we have our final and because we know how much drug we have, it's literally just 1 gram, which by the way is 1,000 milligrams, over 10.8 mils. And that should get you something like 92.6 milligram per mil. And if you're curious why I'm thinking of converting it to milligrams off the bat, it's because it's saying it wants it in milligrams per mil. That gives me a hint. 20 million units of penicillin, powder volume of 8 mils, 32 mils of sterile water. Okay, that tells us all we need to know. So once again, I'm going to write FV, come on, FV, PV, and DV. Okay. We have PV, 8 mils. We have 32 mils of sterile water. Okay. And FV is PV and DV together, so 32 plus 8 is 40. Okay. And now we have our concentration, right? Our final concentration is basically how much drug over our final volume. I'm going to draw a better M. That wasn't any better. Another question about our TPN. 500 mils of 7.5 Travasol, 500 mils of 50% dextrose. We're looking for dextrose this time. So 50%. How many mils do we use? 500. 50 times 500 divided by 100. That's going to leave me with 250 grams. So our 250 grams of dextrose is going to be in what volume? What components did we add to this TPN? We added our dextrose and our Travasol for a final volume of 1,000 mils. So our percent strength formula, X over 100 mils, 250 times 100 divided by 1,000. That's going to be a 25% dextrose. So we have 27 mils of diluent. A vial contains 2.5 grams, powder volume of 3 mils. What is the concentration? FV, DV, and PV. Do we have any of those outright? We have our 27 outright. We have PV outright. So PV and DV makes FV. Okay, how much drug do we have? 2.5 grams, which turns into 2,500 milligrams, 2.5 times 1,000, over our final volume of 30 mils, and then our X over 100 because of our percent strength formula. So how much drug do we have? We have 2.5 grams. And how many milligrams is that? That's 2,500. 2.5 times 1,000. So our final concentration, we need to take our amount of drug over our final volume, which is 30 mils. So 2,500 divided by 30 is 83.3 milligram per mil. 20% solution, diluted to 400 mils. Now it's 5%. What was the beginning volume of the 20% solution? So this one, kind of tricky, but let's think about it. The word "to" is important here. So we know we had a solution in the beginning. It was diluted, and now it's this. Okay. So its current volume is 400 mils. Okay. It's now a 5%. It originally was 20%, but you need to know how many mils it was in the beginning. So let's ask ourselves, okay, how much drug do we have? So we have a 400 ml solution because it says to 400 mils, and it's now a 5% solution. So we know there's 5 grams and 100 mils, and we have 400 mils of it. So because we know that, we can do 5 times 400 divided by 100, and we will know there is 20 grams of drug. Because we know that statement, we know that we can't use any more or any less of the original product. So if we had a 20% in the beginning, and we know we ended up with 20 grams, how many mils do we use? And it's pretty easy, it's just 100. What is the percentage strength of a solution that is made by adding 200 mils of water to 600 mils of a 25% solution? So I'm going to start by drawing this container of a 25% solution, 600 mils. And you're going to add 200 mils. So if you add 200 mils of water, what is going to be the final volume? It's just 600 plus 200, right? So that means it's going to be 800 mils. So all we did was take our original container, we didn't touch any of the part of the drug, and we added 200 mils of water. So we need to ask ourselves, how much drug was that in the beginning? So our 25% was 25 grams over 100 mils, and we had 600 of it. So 25 times 600 divided by 100 is, we started with 150 grams. In the end, we still have 150 grams. So our 150 grams is now over 800. What is the percent strength? You should get there it is. Okay, another penicillin problem. 20 million units. Powder volume of 8. What is the final concentration? 42 mils of sterile water. It's nice and neat. We have 42 mils of sterile water. Powder volume. And PV plus DV is PV plus DV is FV, which is 50. Okay. Final concentration is based off of amount of drug in the final volume, so that's 20 million over 50. Celsius to Fahrenheit, so we need to do our 18 times 9 divided by 5 plus 32. And that's 64.4 degrees Fahrenheit. How much clindamycin, 150 milligrams per mil, is needed to make the following compound? So right there, that's the important part. The 600 milligrams is the important part. You need to just say, how many mils of my product do I need to make 600 mils or 600 milligrams of the clindamycin? So 600 times 1 divided by 150. Two-gram vial, add 10 mils of sterile water, concentration of 180 per mil. We're looking at final volume. Once again, this is linked to FV. So our 2 grams, which is how many milligrams? 2,000, is going to end up 180 milligrams per mil. So our 2,000 divided by 180 is going to be 11.11 mils. That's it. Easy as that. If a patient takes 1 TSP TID, how many mils will be needed for a 7-day therapy? What does this mean? What does this mean? Okay, so it's a teaspoon 3 times a day. But it says how many mils will be needed. So a teaspoon is equal to how many mils? 5 mils. So if they take 5 mils 3 times a day, how many would be needed for a 7-day? So let's go ahead and figure out for 1 day. 5 mils times 3 is 15 mils per day. But they're taking it for 7 days. So we need to do 15 times 7. 105 mils. To prepare 3 grams of Unison, it says to add 6.4 mils of diluent. Concentration is 375 per. What is the powder volume? Okay, 6.4 mils of diluent. Uh, 375 per. Okay, so there, right there is going to lead me to my next component, because this, like I said, when you see milligrams per mil, that means it's already reconstituted. So that means it's already mixed up. It's linked to our final volume. How many milligrams did we start with? 3 grams, 3,000 milligrams. That's going to end up being 375 per. Okay. So our 3,000 divided by 375 is 8 mils. Okay, so what is my 8 mils? If I started with final concentration, that is final volume. So FV is equal to 8. So in that case, what is DV? I'm sorry, what is PV? Well, 8 minus 6.4, 1.6. Back to the one with 3 ingredients, we have 500 mils of 10%, 250 of 70, 350 of sterile water. What's the concentration of dextrose? Well, how much dextrose do we have? 250 of 70%. That means we have 175 grams of dextrose. Final concentration. Okay, so this has to do with the final volume, right? Because we have 500 plus 250 plus 350. Is 1100 mils. That was supposed to be a 1. I'll redo it. 1100 mils. So what percent strength is that? So 175 grams over 1,100 mils is equal to X over 100 mils. And you should get 15.9%. 10 cc's, so boom, right there. I want to stop and hold the brakes because 10 cc's is the same as 10 mils. Don't let that confuse you. Of a 50% is diluted to 100 cc's. So boom, right there. I'm going to go ahead and fix that. 100 mils. Oh. What is the percent strength of diluted solution? Okay, so we started with 10 mils of a 50%. Fifty times 10 divided by 100 is 5 grams. It's diluted 2. So 2, meaning that is our final volume. So we have 5 grams over 100 mils, which is literally the percent strength, right? Because it's grams over 100 mils. So the answer is 5. "95 mils of sterile water is added to 10-gram bulk powder drug. concentration 100 mg per mil. We're looking for powder volume. Okay, let's look for those numbers. 95 mils of sterile water. That is our DV. Okay, we're going to have to pull our final from our concentration because we had 10 grams. 10 grams is how many milligrams? 10,000. Okay, so 10,000 milligrams is going to end up being 100 milligrams per mil. So let's do 10,000 divided by 100, and we'll get, it's going to be 100 mils. So 100 mils is our final volume. And what is 100 mils minus 95? It's going to be 5. The pharmacy has 500 mils of a 16% solution. The technician is asked to dilute it to obtain a 5%. How many mils of sterile water will be needed? So basically, how much is your diluent volume? Okay, so we started with an amount of drug. Okay, we started with 500 mils of a 16% solution. 16 grams, 100 mils, and we had 500 mils of it. How much drug do we have? We had 80 grams of drug. Okay, so we need to dilute it to a 5% solution. So we need to take our 80 grams and put it in an unknown solution to obtain what concentration? 5%. So 80 times 100 divided by 5 is equal to 1,600. So 1,600 is our final volume. So is that my answer? I hope you said no, because we started with a container that was 500 mils, and we did some things to it, and we turned it into, well, this is our unknown. What volume did we turn that to? Well, we turned it into 1,600. Okay. So you're probably thinking to yourself, duh, obviously, we added 1,100 mils because that's the difference. That is in between step A and B. We added 1,100 mils. Back to our clindamycin problem. So back to our clindamycin problem, we have our clindamycin 150 milligrams per mil. How much Cetaphil lotion is being used? So if you remember back in our clindamycin problem, we had a 150 milligrams per mil, and we only needed 600 milligrams. So we only ended up using 4 mils of clindamycin. So what that means is in our ointment or lotion or whatever, this entire thing is going to be right there, 60 mils. So our entire thing is going to be 60 mils. But 4 mils came from that. Okay, so I'm going to color it green. Okay, so you need to find what this is. So How do you think you can do that? Well, it's pretty simple. All you need to do is figure out the difference. What is 60 minus 4? That's 56. A prescription is written for Dilantin 5% QS to 120 grams. How many 50 milligram tablets are needed to prepare? So what you need to do is to understand that it is a weight. So our zinc oxide is actually a cream, so this is going to be weighed by how much it weighs, which is 120. So you're asked to say 5% of your 120 grams. So remember, when you have a percentage, you're trying to find the percentage of 120 grams, you need to convert that to a decimal first, which is divided by 100. You should end up with 0.05. So you need to do 0.05 times 120 grams, which is equal to 6 grams of pure Dilantin, okay? So you need 6 grams of Dilantin, but your tablets are measured in 50 milligrams. So what we're going to do is convert our 6 grams into milligrams, which is 6,000, divide by 50. And you should end up with 120. Okay. If 50 mils of a 12% solution is diluted to 120 mils, what is the percentage strength of the new solution? Okay. So once again, we need to ask ourselves how much drug we have. We have a 12%, which is 12 grams over 100 mils. We have 50 mils of it. And so you're probably saying, okay, that's half, so I have 6 grams. It's going to be diluted to 120 mils. So that's our new volume. What is the percent strength? So 6 times 100 divided by 120 is going to be 5%. All right. 200 mils with 30% solution. You're diluting it to 600. What is the percent strength of the final solution? Okay. We have a 30%, which means 30 grams over 100 mils. And we have 200 mils of it. So 30 times 200 divided by 100 is going to be 60 grams of our product. So our 60 grams now is in 600 mils. So just plug that into your percent strength formula, and you will do 60 times 100 divided by 600, which is 10%. Penicillin problem, 20 million units, powder volume of 8. 72 mils is added. Okay, so this one is a little different because our diluent volume is 72. Okay, our powder volume is 8. So our final volume is the 2 combined, so that's 72 plus 8, which is 80. And then we need to take our 20 million units divided by 80 mils. Wow, that's terrible. So what's 20 million divided by 80? 250K. All right, 2 more. 80 mils with 5% with 10 mils of water. We need the final percent. You start with your 5%. You have 80 mils of it. So 5 times 80 divided by 100 means that you have 4 grams. You're mixing it with 10 mils of water, so that means you're adding to your 80 mils. So your 80 plus 10 mils turns into 90. So your 4 grams is now over 90 mils. What is the percent strength? 4.4%. All right, last one. You're adding 8 mils of sterile water to 5 million units of penicillin, powder volume of 2 mils. What is the concentration of drug in solution? Okay, so we have FV, PV, and DV. 8 mils of water, which is our diluent. Powder volume of 2 mils. So the final volume is the two combined, which is 10 mils total. So we need to do 5 million units over 10 mils, which you probably figured, easy peasy, 500,000. Okay, so I believe that this one and exam 4 are probably the most difficult. So I would strongly advise to work through these a couple times. If you find yourself struggling with a certain concept, make sure you go over it a couple times. And if you have any questions, just let me know.